Hello guys, I, the high schooler doing the simple game engine project, I'm back. Today, I'm gonna explain the collision system that I have written for the game engine. First and foremost, let's have an overview of how I came up with the idea for it. It started with me realizing that when two objects can be marked as colliding, at least one vertex of either of the objects must be inside or on the edge of the other. This made me think of something I'd come across earlier when just starting out, which is point in polygon. Basically, the point in polygon process has a total of 3 steps. The first one is to check if the point is in the range between the maximum and minimum y coordinates of the polygon. For example, take this rotated square, which has a highest y coordinate of, say, 0.6 and the lowest y-coordinate of negative 0.6. If the y-coordinate of the point is within that range, it passes this step. The second step is to form a line that goes through the point, let's call it point A, and parallel with the x-axis. Last but not least, step 3 is to count the number of intersections between the newly formed line with a polygon on either side of point A. If the number is even, point A is outside of the polygon. Otherwise, it is inside. For example, let's take this point A inside of the square, and the number of intersections between the line going through point A and on the right of the point A with the polygon is 1. Therefore, it is inside. In another example, take this point A blatantly outside of the square, and the number of intersections with the polygon on the right side of the point is 2, which is even. Therefore, it is outside of the polygon. So I decided to implement this theory in my collision system. Okay, so here's how I coded it. First, the hitbox coordinates, which are in local space of the objects, will be transformed to their respective world coordinates. And then we iterate through all vertices to determine the maximum and minimum y coordinates of the object. And if the y coordinate of the point is outside of the range, then the function returns false. And then, of all the segments that collectively form the object, all the segments that could possibly intersect with the line we're to form later will be collected using this getIntersectingSegments function, which puts in a vector all segments that has a minimum y and maximum y range within which the point's y coordinate is. Next, the vertices of the object and the coordinates of the point is transformed with the inverse of the collider's model matrix so as to reset the rotation, thus facilitating simpler line casting and calculations while still retaining the relative position of the point. The line that goes through the point and parallel with the x-axis would then be determined using the simultaneous equation function using determinants, which states that if there is a simultaneous equation with this form, Then the simultaneous equation can be solved using this. First, d is equal to a1 b2 minus a2 b1 dx is b1 c2 c2 minus b2 c1, and dy is a1 c2 a1 c2 minus a2 c1, and then x is equal to dx divided by dy is dy divided by d. Now, a few of you may ask why it asks for just two numbers for each equation in the simultaneous equation instead of three, a, b, c. Well, it's because in the ax plus b equals y linear equation, in this use case, the b is always 1, so we only need to input the a and b, which is x and y. And then I will loop through all the possibly intersecting segments that we determined earlier and get their intersection with the formed line if it is on the right side of the point. And then the function will return false if the number of intersection is either 0 or even. And then finally repeat the same process for the x-axis. Additionally, when any instance's collision with another instance is detected, the collision state will be set to true, and the list of collidees of both colliding instances will be added with each other. Here, it is done through this collision state, which just sets the collision state to true and add the collidee. Okay, then I ran the program for testing. Let's run it again. Ignore that. Lol. But it still showed a problem that when the two objects were clearly separate from each other, collision was still detected.
$2,000 later.
I've programmed the object to two objects to only move towards each other when a key is pressed. Yeah, now it works just normally. Yes. Let's just call it a day for now.